Assalamualaikum semua, selamat pagi dan terima kasih kepada
Waalaikumsalam
Ibu.
warahmatullahi wabarakatuh.
Sebelum kita mula kita punya sesi ni,
Waalaikumsalam warahmatullahi wabarakatuh.
kita sedekahkan Al-Fatihah kepada kedua-dua bapa kita, kepada guru-guru kita dan seluruh umat Islam, dan kita mohon juga kepada Ilahi supaya cepat-cepatlah dugaan COVID ni dijauhkan daripada kita dan kita dapat kembali bekerja atau bergerak seperti biasa. Bismillahirrahmanirrahim.
Bismillahirrahmanirrahim. Alhamdulillahirrahmanirrahim. Ar-Rahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in.
Amin ya rabbal alamin. Baik. Bismillah. Sekejap ya, saya nak ambil QR code. Untuk siswa semua, siswi juga, bolehlah untuk download presentation saya kali ini daripada Google Drive ni. Okay, and then kita sambung kita punya discussion kita sebelum ni. Berkaitan dengan basic chemistry, and then again credit to Puan Nur Azira binti Muhammad, lebih kurang 15 tahun dia mengajar di UiTM ni atau berkhidmat di Universiti Teknologi Mara, specialize in cosmetic, natural and synthetic cosmetic. Ini address dia, email address dia. So sekiranya siswa bercadang untuk berubah pendidikan ke arah kosmetik, bolehlah jumpa Pak Ilmah. Dia memang dia punya minat adalah dalam bidang kosmetik saja. Dan beliau juga telah mengajar 10 tahun related to basic chemistry, dan banyak advice daripada dia menyebabkan basic chemistry akan pemahaman pelajar di UiTM atau tahap atau di mana masalah yang dihadapi oleh pelajar UiTM. Saya tak jelas akan keadaan masalah siswa-siswi di UIR, tapi saya menggunakan tanggapan yang sama, yang mana pelajar di UiTM jauh beza dia kecil saja. Harap-harap pemahaman saya itu betul lah, tanggapan saya itu betul. Bismillah. Chemical reactions in chemistry, we examine the natural material or chemical change of the reactions. The reaction itself both may be obvious and predictable. Thus, we can represent the chemical reactions in chemical equations. These are typical chemical equations. For example, potassium bromide. Ini simple reaction saja, tidak balas yang biasa saja. Potassium bromide react with the silver nitrate in a way that we can assign AB chemical, two compound, two molecules, both it is ionic molecules, react and form potassium nitrate and silver bromide. In these reactions, the silver bromide will be form precipitate. Kalau you all tengok di sini, yang ini merujuk kepada dia punya fasa AQ, aqueous. Okay. And then yang ini S stand for solid. Dia dalam keadaan solidify. That's why silver bromide ni akan jadi precipitate, mendakan. Saya pergi secara slow sedikit lah. Because saya ni belajar daripada cikgu saya dulu-dulu, dia suka bergerak secara perlahan. So another example, methane react with oxygen and you give a bit of heat, bakar dia, and we form CO2 and H2O. The compound, the chemical equation ini, it is a balanced chemical equations. Okay. Beri perhatian, a complete chemical equations give you information about the identity, the relative amount of the reactant ini. This is the reactant. Okay, and the product. Okay, and then ada information phase, fasa. It could be solid, depending on the reactions, and in a way that you can designate dia, simbolkan dia sebagai S, or some books they use arrow, downwards arrow. Ke bawah ni merujuk kepada dia precipitate or liquid. L stand for liquid, gas, G, and then upward arrow. Okay. And then aqueous solution, AQ. AQ, aqueous solutions. The rightward arrow, ini simbol dia. It gives the information that from the reactant, react, form direct product, or rightward harpoon, or leftward harpoon, the reaction is not bad. Kata macam mana dia? Dia reactions tu boleh bertindak balas menghasilkan produk, and at the same time the product form reactant. Reactant form product and product form reactant at the same time. A liquid is a state or matter while the aqueous solution is a substance that is dissolved in a solvent water. Ada double arc, saya tak perasan di situ. Dia sepatutnya satu arc saja. Okay. Balancing chemical equations is very important. As a chemist, very, very important on a balancing chemical equations. It allows you to predict how much product can be formed at a given mass of reactant. Okay. Berapa banyak hasil yang kita boleh hasilkan berdasarkan berapa banyak bahan kita gunakan. The abstract information, for example, how much heat released when the reactant react and a pressure change, depending on the type of the reactions lah. Okay. Yang ni exercise ni a basic exercise. Before we understand, we can do balancing chemical reactions or chemical equations. At the very least, you should be able to identify the molecule or compound. molekul atau compound ni saya dah touch pada lecture yang pertama. Di situ you ada boleh tengok covalent compound, ionic compound, polyatomic compound, polyionic compound. Exercise ni boleh dibuat pada bila-bila masa ya pelajar-pelajar free lah. Okay. In balancing chemical equations, what you need to know or to master ability to write the reactions. Okay. Kebolehan menulis reactions. That means compound tu adakah ia ionic compound ataupun just a molecule NH3, for example NH3, or salt, or acid, or hydrocarbon, or carboxylic acid, and so on. Ada banyak compound. So, sangat-sangat kritikal untuk pelajar boleh menulis reactant tu atau produknya. And then bila you boleh menulis reactant tu, then you boleh balance the chemical equations. Mana ni? Okay, so then can balance the chemical equations. And then from there, the chemical reactions that you can predict now. So how to write the chemical equations? Okay. Again, a chemical equation is the simplest way to show a chemical reactions, or some books put in the chemical processing can also, or the method the chemical reactions, mechanisms. It shows the starting material or substance or molecules or compound or composite in which we can call it as a reactant. Okay. And then when the reactions occur, let's say it's occur, it will produce a new substance that we call a product. Okay. Reactant, product. So could be, let's say A is a reactant, then the reactions form a product B. There will be composition different in terms of composition and its amount of it. The equations can be written in the words, and in a way that we call this word equations, or we can write it in a formula, which means that chemical equations. Okay. So, for example, for chemical equations, let's say calcium carbonate decompose. This is in terms of word equations. Also that we can write it as calcium carbonate. This is the reactions, and it form a product, calcium oxide and carbon dioxide. Okay. The chemical equations in terms of formula for decomposition, potassium chloride, you heat it up, you akan hasilkan potassium chloride and oxygen. Magnesium react with sulfuric acid. The word equation there. Magnesium react with sulfuric acid, produce magnesium sulfate and hydrogen gas. Anyway, that if you write in a formula, magnesium, sulfuric acid, H2SO4, from magnesium sulfate, salt, and the gas. Okay. All chemical equations must be balanced. Ini very critical. Semua tindak balas kimia mesti seimbang. Okay. So both sides of the equation, before and after, must have the same number of atoms of each element, because atoms do not disappear in reactions. Okay. Atom ni selepas tindak balas tidak hilang, dia akan kekal ada di situ. And what you need to do is add extra number to the equation to make it a balance, but you are not allowed to altering the formula of the substance in the equations. That's why chemical formula ni sangat penting ya. Formula of substance tu sangat penting. For example, sodium chloride, it must be NaCl. You cannot change it to Na2Cl. This is wrong. Okay. Yang ni kita pakai sodium chloride. Sodium chloride will always be like this. A balanced chemical equation stands about the number of atoms and the molecule reacting together in the reactions. So how to balance the chemical equations? Ada tips dia. Tips ni saya pun tak jelas daripada mana saya dah ambil. Dia lama dah. First kali kita balance the metal element. Metal element. And secondly, you baru nak balance, siswa semua boleh seimbangkan non-metal element. And then bolehlah balance element oxygen and hydrogen atom. Okay. Untuk balancing oxygen or hydrogen, it is up to you. You can start with hydrogen or oxygen, depend, ikutlah. Tak ada masalahnya, tak ada kekangan di sini. Okay. Ini contoh dia. For balancing chemical equation, student sekarang ni suka menggunakan algebra konsep. Ini yang dimaklumkan oleh Puan Azira kepada saya. Okay. Yang mana you suka split step atom tu. In a way that over here, sorry, R over here stand for the reactant, P over here the product. So something like this, yeah. So Na, sodium, this is the reaction between sodium with water and form sodium hydroxide. First kali, this is the reactions there, but then we need to check, is it balanced or not? Okay. Looking from here, kita tahu dah sodium ini satu, ini pun satu dia punya nilai dia, so balance, sodium saja, But then when you take a look at the atom of hydrogen, ada 2. And di sini ada total dia adalah 3. That's why you need to do a balancing. For sodium, Na, you can describe the notation with A and as a reactant, and for the product dia sebagai P. And then sepatutnya A and C ini, A and C, P, produk P, notation dia C, A and C ni mesti sama. First konsep tadi kena tahu atom tak hilang. Okay, when the reactions occur, atom from the reactant to the product tak hilang. Dia akan kekal ada quantity dia. And then while for the hydrogen, atom hydrogen, 2B, because the 2 here, B, and then 2D, and C, because C only 1 hydrogen for C plus 1 C. And then oxygen, B ada 1 saja di sini, atom oksigen, 1B, B saja, equal to 1C, 1C. In total dia, you tengok di sini, sebelum balancing, dari reactant tu ada 4 atom. Sekiranya kita tidak melihat jenis atom dia, number dia adalah 4. Total bilangan dia. But then when looking from the product side, on the right side of the reactions, kita ada berapa ni? 1, 2, D ni ada 2 juga, 4, plus another C, so 5. So residue number dia memang di sini sudah tak balance. Okay. And then we also know that, so for A ada 1 saja equal to 1, and C equal to 1 juga, ke 1 saja dia punya depannya, and also B equal to 1. So because of that, kita boleh tentukan D ni. Okay. So we can calculate the D, substitute D, you akan dapat D equal to half of it. Okay. So nak balas yang tadi ni, just write back. And then untuk 1 tak perlu ditulis, tak perlulah, tak payah ditulis di situ. And D ni, we only need hydrogen ni, we only need half of it. But then hydrogen gas exists in H2. So biasanya half ni kita tak tulis, kita nak balas macam ni. Walaupun dia betul, masih diterima betul, but we write it something like this. It must be in whole number, nombor bulat, angka besar. Dan oleh kerana kita nak buat nombor bulat dia, yang ni kita darab dengan 2. So bila didarab dengan 2 times with 2, and dia become 2 sodium, 2 H2O, react with 2 H2O from 2 sodium hydroxide and 1 hydrogen gas. What I mean by 2, 2, 1, 1, this one, 2, 2, 1. So the 2 over here represent 2 mole of sodium. Okay. 2 mole of sodium. React with 2 mole of water, produce 2 mole of sodium hydroxide and 1 mole of hydrogen gas. Okay, again, 2 mole of sodium react with 2 mole of water and it produces 2 mole of sodium hydroxide and 1 mole of hydrogen gas. Okay. Or you can say it, 2 mole of sodium form 2 mole of sodium hydroxide. Okay. NaOH. Another example, TiO2, BrF3, tindak balas ni hasilkan TiF4, Br2 and O2. So, for tindak balas ni, the reactant still over here, group reactant, and this is the group product. Again, number of atom in the reactant site for that particular atom must be the same as the right side. Okay, mesti sama kuantiti atom dia. So bila kita lihat dari sudut tindak balas dia, or make it into looking from algebra side, oxygen over here, notation just A, B, C ni, ini hanya simbol yang you boleh letak. Kalau you suka Z, F, G, E, boleh, tak ada masalah, tak ada halangan langsung, tak ada satu bentuk kemestian di sini. Okay. So over here, 2A, and then because oxygen here E, you put it as E, we put it as E, 2E. Okay. Oh, terlupa di sini, titanium dia terkeluar, tergerak sedikit. Titanium, A, satu saja titanium, satu saja atom titanium di sini, equal to C, titanium di sini pun satu juga, C. Okay. While for bromine, bromine pun satu, that's why B saja, equal to bromine di sini ada dua, Br2, so 2B, 2D, sorry, 2D. Okay, while for fluorine, 3B, ada 3 atom fluorine, so 3B, and then dilihat pada produk, fluorine 4C, ada 4 lah, di sini ada 4 di sini. Okay. So 4C. So in total dia, disregarding the type of atom, 1, 2, 3, 4, 5, 6, 7, ada total 7 atom pada reactant side, while for product side ada 9, 4, 5, 6, 7, 8, 9. Okay, 4, saya tukar color sekejap. 4 plus 2, 6, 6, plus 2, 8, and another plus 1, 9. So that's why kita dapat 9 di sini. So chemical reactions ni is not balanced. So first rule dia, you kena balancekan dia macam mana pun. So again, we take a look, because A equal to 1 and let's say C equal to 1 juga, assumption here, 2A equal to 2E, 2A, 2E. Okay. So here. A equal to 1 and E equal to 1 juga. 3B ini 3B equal to 4C. Okay, 4C. And this is 4C. While C equal to 1, so B adalah 4 divided by 3. And then if you take a look on 2D, equal to 4 over 3, so you akan dapat D adalah D equal to B. Okay, B over here sepatutnya D equal to 2D. So D equal to B over 2. So that's why you akan dapat ini. D, mana dia ni? D 2 over 3. So tindak balas ni daripada sini, because you dah mengetahui, kita dah mengetahui akan D tu berapa dia punya numerical number dia, and B dia punya represent dia apa benda, number dia. So again, persamaan ini, tindak balas ni, kita just salin balik, just write balik, and then we substitute B equal to 4 over 3 and D 2 over 3. Okay. And then untuk chemical reactions ni, kita lihat tak nak dalam keadaan pecahan. Because of that, tindak balas ni, kita times with 3. So then finally, you akan dapat 3 mole of titanium oxide react with 4 mole of BrF3, producing 3 mole titanium tetrafluoride and 2 mole of bromine, gas bromine, and 3 mole of oxygen, gas oxygen. Yang ini ni balancing for chemical equations. Okay. Bit of balancing chemical equations. Boleh tengok, kita cuba. Kita cuba supaya you all boleh faham sedikit. Boleh ke kalau kita cuba untuk detail sikit, kita cuba untuk exercise nombor 2 sekejap. Saya pergi ke exercise nombor 2. Exercise nombor 2. For example, untuk ini kita cuba ya. Write the balance equations, chemical equations for following reactions of zinc sulfide react with oxygen that produce zinc oxide and sulfur oxide. Right. First sekali kita kena tahu zinc sulfide lah. Oops. Kalau zinc sulfide ni, sekiranya pelajar tidak mengetahui di mana nak cari, tak simpan zinc sulfide. Dan simbol dia di sini you akan dapat formula dia. Chemical formula dia zinc sulfide ZNS. So sekejap saya nak pergi ke mana ya. Ini. Oh, tak susah. Saya pun dah terlupa dah soalan dia. Ini ada soalan dia. Zinc sulfide react with oxygen and produce zinc oxide and sulfur oxide. Sulfur oxide again lah. Sekiranya pelajar tak mengetahui, boleh Google lah, gunalah informasi yang kita ada untuk memudahkan kerja. Cara pertama yang saya ingat daripada cikgu kimia saya yang pertama, cikgu Asia, dululah, berapa lama dah, 25 tahun yang dahulu, bukalah buku. Sekiranya tak mengerti, tak ingat, tak ada masalah, buka buku. Untuk zaman kamu, sangat mudah di mana you boleh Google. Dan most of information yang ada di Google ni agak tepat. Sulfur oxide. Dan sulfur oxide tu, take a look on the formula. SO2. Okay, SO2. So here, okay, come back to kita punya tindak balas ni. Di sini kita boleh lihat, kita semua boleh tengok. Oh, sudah tekan silap. Tindak balas ni tak seimbang. Okay. Yang mana elemen oksigen di sini tak seimbang. Baik, bila elemen tak seimbang, yang mana dari atas side ada 2, the right side or the product side ada 3. Okay. So kita perlukan Ini saya permudahkan sedikit lah. Half of it lah. Half of it, oksigen atom ni dibagikan, kalau molekul ini kita bagikan dengan 2, perkali kita letak perkali 2, kita akan dapat tindak balas yang seimbang. But still, bila tindak balas kimia, nombor dia mesti dalam keadaan genap, tak ada dalam keadaan pecahan. Because of that, you boleh letak sini 2. Tindak balas ini perlu dikali dengan 2, didarab dengan 2. So, ia akan dapat 2 zinc sulfide plus 2 oxygen produce 2 zinc oxide and SO2. Okay. So, ini tindak balas yang paling simple sekali. Pelajar semua, siswa semua jangan risau berkaitan dengan exercise ni. Ianya lebih untuk kamu mengetahui kedudukan kamu di mana. Exercise bukan untuk satu penilaian untuk di UiTM. Saya tak menggunakan exercise untuk penilaian dalam satu-satu kursus. Dia lebih kepada penilaian terhadap diri kamu sendiri. Kamu menilai kedudukan kamu sendiri itu di mana. Terutamanya dalam keadaan COVID ni, sangat sukar untuk saya dengan student saya melihat dia punya progress itu. Dan pelajar di UiTM ni, di UiTM kita ni, sangat sedikit pelajar yang bagi feedback akan masalah yang mereka hadapi. Saya tak pasti dengan keadaan di UIR macam mana, tapi inilah yang agak sedih kalau di peringkat saya lah sebagai mengajar, apabila tidak mengetahui akan masalah kamu dan dia akan menjadi beban kepada pelajar, bukan kepada pesyarah, pada saya. Atau sedih jugalah bila dibuat test yang mana daripada test tu markah tu akan diguna pakai dan di situ mulalah student tak boleh nak menjawab dan kesilapan yang kecil-kecil sangat kritikal hingga akan menyebabkan markah tu hilang banyak. So saya harap pelajar semua janganlah, cubalah contact you punya supervisor, you punya lecturer, ada masalah bagi tahu kepada pesyarah supaya boleh kami bantu. Dan you all boleh contact saya sekiranya ada masalah berkaitan dengan balancing chemical equations, related to polymer. Kalau di UIR itu ada subjek related to polymer, boleh contact saya. Dan nombor telefon saya you all pun ada hadir dah daripada lecture yang pertama dulu. So for chemical reactions in a aqueous solution, a solutions for you, it is a homogeneous mixture, campuran yang sekata seimbang, whereby a substance present is a lesser amount that we call a solute, and it disperses uniformly throughout the substance in a greater amount the solvent. While for the aqueous solution, it is a solution in which the solvent is water, whereas in a non-aqueous solution, the solvent itself is a substance other than water. For di sini, we focus on reactions that occur in aqueous solution. Tindak balas yang mana menyebabkan water. Because of that, we need to take a look on the properties of water, bit properties of water. Sambil-sambil tu, maaf saya minum air sedikit, dahaga. Keren tekak. Water, it is an individual molecules that consists of two hydrogen atoms bond to oxygen atom. Okay, ada bonding di situ. Oxygen atom in each OH bond here attract electron more strongly than hydrogen atom, and the oxygen and the hydrogen nuclide do not equally share the electron. Because of that, the hydrogen atom become partially positive, delta positive, while for the oxygen atom become partially negative, delta negative. These unequal distributions of charge, positive, negative charge ni, create a polar bond and make it then a good solvent for ionic compound. Okay. So when ionic solid or ionic compound dissolve in water, the ion deassociate. Okay. Sodium chloride, you add a water in your liquid, and then you agitate it, so make it separation between the sodium Na plus with Cl minus faster, or you can heat it up a bit up to maybe 50 or 40 degree. You will produce sodium ion, cation, and chlorine ion, anion. This is how salt form. So tak ada voice kali ni, tak ada. The polar charge of water, bipolar. We go for the opposite attraction there. The positive, we go to the negative. So the charge negative, the anion, Cm. And then the extraction will continue with charge positive and keep on continuing until all solid sodium chloride dissolve. Okay. For precipitation reactions, it is a reactions that produce insoluble product, precipitate, mendakkan. For example, a mixing of two solution, colorless silver nitrate, red is plus or mixing, red with potassium chloride, okay, yellowish potassium chloride, that will give reddish or red color precipitate of silver chloride. Okay. But this is a potassium silver nitrate. Potassium chloride, both in a solution, produce silver chloride. In a solid, it's a precipitate. That's why we put it as a solid S, in bracket solid S, solid precipitate. Dia akan jadi mendakkan. And then potassium nitrate. aqueous. Because both components of each compound change partner, this reaction we call it as a double displacement reactions. Sorry. Dalam saya letak biasanya pukul 10, saya akan berhenti sekejap untuk minum air. Cepat sikit. Saya mudah terlupa untuk minum, untuk makan bila bekerja. So, kena letak alarm. So, as a reminder lah. Ini simple tindak balas untuk silver chloride, precipitations of silver chloride. Okay. So, sebagai siswa-siswi, you all kena ada kebolehan menentukan tindak balas. So, ada a few simple rules yang boleh diikuti. Yang ini diguna pakai di UiTM lah. Untuk peringkat UiTM kami guna pakai yang ni rules ni. Dan rules ni terpakai untuk basic chemistry saja. Bila you belajar untuk chemistry peringkat atas, subjek chemistry atas, certain rules tak boleh dipakai lagi. Okay. Untuk yang ni kemungkinan besar boleh diguna pakai. Di UiTM kita pakai. Untuk di UIR, saya mohon yang ni rujuk dengan pensyarah kamu untuk lihat keadaan dia macam mana. Boleh guna atau tidak. For example, rules yang pertama yang kita boleh pakai, most salt that contain alkali metal, lithium, sodium, potassium, rubidium, cesium, and ammonia will be soluble in water. Okay, in aqueous medium. Dan kemudiannya, kenapa masih rule 1 ni? Dia sepatutnya dah jadi rule 2 ni apa ya? Most salt containing nitrate, NO3- anion, it is a soluble. Okay. And most salt of anion derived from monocarboxylic acid, CH3CO2-. Okay. Are soluble. And then, silver acetate and long chain carboxylate are not soluble. Okay, are not soluble. Long chain ni macam mana nak tengok? Kita tengok on the number of CH3 yang ini. Sekiranya ni number ni dah banyak, contohnya C3, C3 ni H berapa? 2, 4, 7. CO2- dah jadi dah menjadi non-soluble dah for certain case lah. Okay. And rule 4 dia, most chloride, bromide, and iodic salt is soluble, but then copper chloride, GMT chloride is not soluble. And then for insolubility juga ada rule 5 dia, seterusnya peraturan dia yang kita guna pakai. Most site containing the hydroxide H- and sulfur as anion. Okay. With pengecualian dia, compound or ion compound containing group calcium hydroxide is soluble. Sodium hydroxide, soluble, and then barium 2 plus soluble juga hydroxide lah. And then ammonia sekali. And root C dia, rule yang ke-6, dia peraturan ke-6 yang kita pakai. Ini peraturan ni, peraturan ni terpakai di peringkat yang rendah sahaja. Most carbonate ion, compound, tak soluble, tak larut. Also phosphate juga. But then, with alkali, dia akan jadi soluble. Alkali metal dia akan jadi soluble. Carbonate itu dengan alkali metal dia akan jadi soluble. And then most sulfate salt are not soluble, insoluble, not soluble, containing main group of cation with a charge more than 2 positive. But then for salt with a positive one cation, Mg2 plus, and dipositive transition metal cation, it is a soluble to SO4 to minus. And then for solution, still for solution reactions ni, chemical reaction in solution, we are looking on over here acid-base reactions. Acid-base reactions are very important in both biochemistry and industrial chemistry. More or many of the substance that we encounter in our life, for example, medicine, paracetamol, aspirin, and acetylsalicylic acid, antacid, are base that we use for antacid ni for treatment gastritis. Okay. Acid untuk gastritis ni, kita panggil dia, di Malaysia ni kita panggil dia kembung, perut kembung. Okay. Perut kembung atau sakit perut lah. Perut berasid. So you need to add a base compound to make sure it neutralize your stomach. Acid are substance that dissolve in water to produce a proton, H plus ion. Okay. While for base, a substance that dissolve in water to produce hydroxide ion. Okay. Ini konsep asas saja ya. One of it produce H plus, another one produce H minus. Okay, kita tengok acid ya.
From the tangy bite of a piece of fruit to the caustic liquids used to clear a clogged sink, acids are a type of chemical that could be found in many different aspects of our daily lives. But what is it about acids that makes some safe to eat and others dangerous? When talking acids, we're going to be talking hydrogen. Not the gas, but rather the hydrogen ion H+. This is a hydrogen atom that has lost its one and only electron. All acids produce H+ ions when dissolved in water, but it's how much H+ a specific acid can produce in water that will determine whether it can be safely eaten or not. But how do we conceptualize and measure H+ concentration? Søren Sørensen, a Danish chemist, pondered this question when he worked at the laboratories of a commercial brewery in Copenhagen. It was in 1909 that he developed a method of quantifying acidity, what is now known as the pH scale. His scale works by simply converting the concentration of hydrogen ions in a solution to a number between 0 and 14. If a chemical is acidic, then its pH will always be below a 7 on the scale. The lower the number, the higher the hydrogen ion concentration. The pH scale is a logarithmic one, meaning that 1 unit difference on the scale, say from 3 to 2, means a 10-fold difference in H+ concentration. But 0 to 7 is only half of the picture. So what about all these numbers above 7? Substances that correspond with this half of the scale are called bases, and they are the chemical opposites of acids. The 7 on the scale represents neutral pH, what would be perfectly pure water. Like acids, bases are found in chemicals that we encounter in our everyday lives. Cleaning products such as ammonia and baking soda are bases, as are some simple medicines like milk magnesia. They're bitter to the taste and often slippery to the touch, kind of like soap. Even though bases are different than acids, they too can be strong or weak, and a strong base can be just as dangerous and corrosive as a strong acid. Chemically, the difference between acids and bases is that acids produce hydrogen ions and bases accept them. In water, acids produce H+ ions and bases produce OH- ions. In reactions between acids and bases, hydrogen ions will react with hydroxide ions to make water. This type of chemical reaction is called a neutralization reaction. Acids and bases are also very important in biochemistry. Many biological processes are sensitive to the pH of the surroundings, so controlling acidity in the body is crucial. Some biologically important molecules like amino acids have dual personalities. They're said to be amphoteric, which means that they can act as both acids and bases. An amino acid has a carboxylic acid group that can produce hydrogen ions and an amino group that can accept hydrogen ions. Acids and bases are all around us and can vary greatly in terms of their use and their nature, but they all involve hydrogen ions being passed around. Thanks for watching. If you would like to learn more chemistry basics, make sure to check out these other interesting videos in the series. From the tangy...
This is a few classifications of acid, typical acid that we use in our class, the ATM ini. Strong acid, for example, hydrogen halide, HCl, HBr, and HI. Or also acid. Also acid is acid that contain oxygen. Nitric acid, sulfuric acid, and chloric acid. Okay. While for the strong base, it is a base from group 1, lithium hydroxide, sodium hydroxide, potassium hydroxide, and so on. And from group 2, calcium hydroxide, strontium hydroxide, barium hydroxide. Okay. For neutralization reactions, it is a reaction in which acid and base react in stoichiometric amount to produce water and salt. Okay. Produce salt and water. Sambut boleh salt and water boleh, tak ada masalah. Water and salt. In here, this is an example of reactions. Again, kalau you tengok, ini adalah reactant, ini adalah product. Okay, reactant, product. So, ini adalah acid. Okay, hydrogen bromide. Ini adalah base, sodium hydroxide. So, tidak balas ini, we produce always between acid and base, we always produce water and salt, garam. Tak, ada garam yang boleh kita guna, ada setengah garam yang kita tak boleh pakai. Sodium bromide ni kita tak boleh pakai, sodium bromide. Tak boleh guna untuk pakai di mananya untuk makanan lah, yang saya masukkan di sini. So di sini, if we take a look, base react with the base react with the acid, produce water, H2O, molecule water you dah tahu, H2O, and then salt. Untuk salt ni, be extra careful. You need to know, first one, base over here, the type of a cation over here, and the type of anion over here. And luckily, for example, ini saya nak bagi contoh yang simple saja. So, sodium tu Na+, kata dia charge satu positif saja, while for Br charge minus negatif, anion, negatif 1. So dari situ, dia akan dapat NaBr. NaBr ni, ada dalam lecture notes yang sebelum ni melibatkan naming of ionic compound. Okay. Bolehlah tengok kembali. Daripada tindak balas ni, kita tahu elemen of the product side and the reactant side sama sahaja. Di sini ada hidrogen untuk the reactant side, ada hidrogen 1, 2, and the product side ada 2 hidrogen. Bromine ada 1 atom dia. Di sini pun ada 1. While for sodium Na ada 1 di sebelah reactant, ada 1 di sebelah product, and then oxygen only one in the reactant side and only one in the product side. So this reaction is balanced. Okay. It also means that 1 mole of acid react with 1 mole of base produce 1 mole of water and 1 mole of salt for this reaction. Kita tidak balas ini. While untuk tindak balas ni, this is a beautiful reactions. Okay. HCl, acid, NH3, ammonia. Okay. Ammonia quite special. Please take a look how ammonia NH3 react with water. Okay. And how it changed to when NH3 react with water, form a base NH4 plus OH minus. Please take a look. Okay. Yang ini it is a weak base. Okay. And then yang ini tindak balas between with acid with a strong base. Okay. And form a salt and water. Okay. Yang ini tu salt saja in aqueous medium. While yang ini sama saja ni, compound ni adalah compound yang sama saja, cuma cara penulisan tu berbeza. Yang di sini O tu saya letak 2 saja di sini. Represent 2O here juga. Okay. React with the weak acid, react the weak base, and it form salt. So nak balas terusnya untuk aqueous medium ni, aqueous solution ni, acid react with most metal to form a salt and gas hydrogen. Okay. For example, if you introduce solid zinc into hydrochloric acid, you akan hasilkan zinc chloride and gas hydrogen. Okay. Right. So zinc chloride and gas hydrogen. And also, when base react with a certain metal, for example zinc or aluminium, it produce hydrogen gas. Okay. So untuk tindak balas ni jaranglah kita tanya kepada pelajar di UiTM Police, di UiTM keseluruhannya, kita jarang tanya because it's quite unique tindak balas ni. Tindak balas reactions between the base and metal, it's very unique. So kita consider it as a high level questions. High level questions ni kalau ditanya pun markah dia about 3 to 4 marks only per questions. So by understanding the balance chemical reactions, understanding the reaction itself, and then be able to balance it. You can use the information from the balanced chemical reactions to couple with the law of conservation, whereby the total mass of substance after reactions equal to the total mass of substance before reactions. Or certain books put it more simple, total mass before reactions equal to total mass after reactions. It is up to you. Pilihlah buku, certain books dia persamaan tu, equation ni dia letak agak diubah, agak berbeza sedikit. Cuma maksud tindak balas tu tetap sama. Maksud law tu tetap sama. And then you have the law of constant composition yang kita pakai tadi. All sample of a compound have the same composition, the same portions of the same proportional by mass of the constituent element. Okay. And then we use juga, by the way kita guna juga pada masa yang sama, law of multiple proportions, whereby if a two element from more than a single compound, the mass of one element combined with a fixed mass of the second in the ratio of small number. And then later kita akan tengok Avogadro law in a way that a total number of atoms or molecule of a gas, it is whereby the amount of gaseous substance is directly proportional to the volume occupied by the gas at constant temperature and pressure. PV equal to nRT, it is ideal law lah. Daripada situ, yang penting untuk kemis ni, kita melihat pemahaman pada sudut atomic mass unit. Yang ni atomic mass unit kita dah sentuh, saya dah sentuh lecture sebelum ini. And then relative atomic mass unit, in a way we take a look on the compound and we calculate their mass. Okay. Relative molecular mass, ionic compound. And relative relationship between the mole and the mass, whereby mole equal to mass divided with relative atomic mass or relative molecular mass. Okay. And then relationship between the mole with the Avogadro number, later kita akan tengok, and calculate the percentage of composition of compound. Dah kita sentuh sebelum ini, and kita ada sentuh juga empirical formula and molecular formula sebelum ni. So just a recap, kritikal ni, mole ni, calculation of mole, kesilapan yang kerap sangat dibuat oleh pelajar. Kerap sangat pelajar di UiTM buat kesilapan. Okay. Kecuali lah. Kesilapan di sini dibuat ada dua. Satunya, formula molekul untuk compound tu tak betul, tak tepat. Okay. For example, sodium chloride NaCl, but somehow it become Na2Cl or NaCl2. Jadi tak tepat di situ. And then kesilapan yang kedua, let's say formula tu dah betul, NaCl. Kesilapan yang keduanya, kerapnya, semasa menggunakan periodic table. Okay. Periodic table, sekejap ya. Jadual berkala. Ini jadual berkala. Okay. For NaCl, kita tengok di sini, kita tengok pelajar tu akan tengok ada dua number. untuk sodium ada Na 11, simbol di sini ada 11, Na and then 22.99. Okay. Di sini pelajar kerapnya tertukar relative atomic mass untuk sodium. Diambilnya 11. Diguna pakainya 11. While the numbers supposed to be depend on the type of particle table yang you pakai. It could be 22.99 or 23. Okay. And then same case, Cn ada dia pakai proton number. Itu kesilapan yang kerap sangat, yang sedih sangat. Saya lihat untuk pelajar saya lah, sekiranya mereka membuat kesilapan ini sangat sedih. Dia ambilnya 17 dia sebagai relative atomic mass, while it's supposed to be 35.45 or some put it as 35.5. Okay, depending on type of particle table that given to you. So, and then kesilapan yang keduanya, bila mencampurkan sodium and chlorine, berarti atomic mass-nya. Okay. So, please, pelajar semua, siswa semua, berhati-hati bila menggunakan particle table. Please, sangat-sangat berhati-hati. Sayang sekiranya you buat kesilapan di sini. So untuk number of mole, you can calculate from the information that involve mass and molar mass, or based on a number of particles, or take a look on the volume and molar volume, and using the molarity or the volume. Okay. For relationship between the number of mole with a number of particles and the mass of substance and volume of gas. Ini formula dia ya. Formula ni tak berubah ya. Kekal saja. So number of mole of particle equal to number of particle divided with Avogadro number. And the number of mole for substance, the mass of it, the mass of substance, and the molar mass there, the molecular mass there. And then for number of mole for gas, equal to the volume of gas divided with the molar gas volume. Okay. For gas, 1 mole of gas we occupy 22.4 cubic decimeter, or equal to 24,000 cubic centimeter at standard temperature and pressure, whereby the standard temperature will be 25 degrees Celsius, and the pressure, standard temperature, pressure will be 1 atm. Okay. And then this is just a simple conversion in a way that 22.4 cubic decimeter equal to 22.4 liter of gas. For any gas, huh? Okay. Ini another kesilapan yang sangat-sangat kritikal, sangat-sangat menyedihkan lah. Yang mana pelajar tidak mengetahui prefix. Okay. For example, GM, it means giga, 10 to the power of 9 gigameter. Or M, mega, 10 to the power of 6, faktor dia. Kilo 10 to the power of 3, kilometer. Deci 10 to the power minus 1, dm. Decimeter atau dl apakah boleh pakai tu. Senti, ini berhati-hati ya pelajar semua. Yang ni prefix ni kerap sangat kesilapan dibuat. Untuk kami di sini, biasa kita menguji akan pemahaman pelajar terhadap benda-benda yang simple, benda-benda yang asas. Kalau kita melihat sekiranya asas tu pelajar tak mengetahui, untuk kod yang awal ni, kod peringkat bawahan ni, bagaimana mereka akan bergerak pada kod-kod yang atas, sajak-sajak yang peringkat yang lebih tinggi. So agak kritikal berkaitan dengan sentimeter ni, desimeter, mili, 10 to the power of 3, minus 3 untuk mili, micro 10 to the power of minus 6, and so on. Okay. Yang kerap juga berlaku di, saya lihatlah, student peringkat atasan yang mana dah hampir nak graduate tidak boleh buat conversion between centimeter to decimeter or between milliliter to liter. Yang ini sangat-sangat menyedihkan lah, because kita sebagai pensyarahkan ni lah, yang mengajar saya sebagai pensyarah, akan sedih sekiranya pelajar tak mampu untuk buat conversion. Saya harap you all tak jadilah macam tu. And then kita ada juga untuk gas law. Gay-Lussac's law.
For a gas, temperature and pressure are directly proportional. When you keep everything else constant, as the temperature of a gas goes up, its pressure goes up. As the temperature of a gas goes down, its pressure goes down. If you heat up a gas, the gas particles move faster. If the gas is in a solid container with fixed volume, this means that the faster the gas particles move, the more times per second they collide with the sides of the container. That registers as increased pressure. The converse is also true. If you cool down this container of gas, that means the gas particles are moving more slowly. So there will be fewer collisions with the sides of the container per second, which means lower pressure. Joseph Louis Gay-Lussac shares credit with Guillaume Amonton for establishing a gas law describing the relationship between temperature and pressure. Gay-Lussac's law says that when the volume and amount of gas is constant, pressure and temperature are directly proportional. P is proportional to T. You can write this mathematically as P equals KT, where P equals pressure, T equals temperature in Kelvin, and K is a proportionality constant. We can rearrange this equation so it reads P over T equals K, or the ratio of pressure to temperature is a constant, K. Very often, Gay-Lussac's law is used to compare two situations, a before and an after. In that case, you can say P1 over T1 equals K, and P2 over T2 equals K. So you can write Gay-Lussac's law as P1 over T1 equals P2 over T2. Let's see an example. A canister of nitrogen gas has a pressure of 2,000 psi, pounds per square inch, at 20 degrees Celsius. What will the pressure be if you increase the temperature to 25 degrees Celsius? Let's write down Gay-Lussac's law, P1 over T1 equals P2 over T2, because we have a before and after. Remember to convert the temperatures to Kelvin. Kelvin equals degrees Celsius plus 273.15. So T1 equals 293.15 Kelvin, and T2 equals 298.15 Kelvin. Substitute in what we know. 2000 psi over 293.15 Kelvin equals P2 over 298.15 Kelvin. Solve for P2. Multiply both sides by 298.15. P2 equals 2000 psi times 298.15 Kelvin divided by 293.15 Kelvin. P2 equals 2034 psi. Here's another example. At 10 degrees Celsius, a gas exerts 0.95 atmospheres of pressure. At what temperature in Celsius will it exert a pressure of 0.75 atmospheres? P1 over T1 equals P2 over T2. Remember, we have to convert temperatures to Kelvin. Kelvin equals degrees Celsius plus 273.15. So T1 equals 283.15 Kelvin. 0.95 atmospheres divided by 283.15 Kelvin equals 0.75 atmospheres divided by T2. Solve for T2. T2 equals 283.15 Kelvin times 0.75 atmospheres divided by 0.95 atmospheres equals 223.54 Kelvin. We're not done yet. Remember, we have to convert our temperature back to Celsius. 223.54 Kelvin minus 273.15 equals negative 49.6 degrees Celsius. Gay-Lussac's law relates temperature and pressure for a gas, but there are other gas laws which relate the other essential variables associated with a gas. Charles' law is the relationship between temperature and volume. Boyle's law is the relationship between pressure and volume. And the combined gas law puts all three together: temperature, pressure, and volume. Notice that to use any of these laws, the amount of gas must be constant. Avogadro's law describes the relationship between volume and the amount of a gas, usually in terms of N, the number of moles. When we combine all four laws, we get the ideal gas law. To decide which of these gas laws you need to use when solving a problem, make a list of what information you have and what information you need. If a variable doesn't come up or is held constant in the problem, you don't need it in your equation.
Okey, ini Dalton law.
Hi, this is Dr. McCord. I'm going to talk to you today about Dalton's law of partial pressures. We're going to start out with the ideal gas law, which is PV equals nRT. We're also going to solve for P here and just get it written in terms of the number of moles, the temperature, and the volume. We're also going to hold the temperature and volume constant so that we can split out the RT over V term. We're going to call that a constant. And this really allows us to kind of think about pressure only in terms of the number of moles. What that means is pressure is directly proportional to the number of moles. So it's real easy to think about the calculations here. So if you double the moles, you double the pressure. You triple the moles, you triple the pressure. You get the idea. So we're going to first start with a container here. If you need to know what the container size is and the temperature, we'll go ahead and give you that. 244.7 liters at 25 degrees C. Now we're going to put 1 mole into this container and we get 0.1 atmospheres of pressure. We're going to then double this up to 2 moles and we're going to get 0.2 atmospheres of pressure. And as you can guess, if we go to 3 moles, we get 0.3 atmospheres of pressure. And this becomes really easy to just keep going, count 4 moles, 5 moles, go all the way to 6 moles, you'll get 0.6 atmospheres of pressure. You go to 7, you'll get 0.7. And we'll take this all the way up to 8 just to make a point. But we really want to shift our focus now into several containers combining to make a mixture. So let's imagine we have 3 containers like this and explore Dalton's law of partial pressures. So here's 3 containers. We're going to label them A, B, and C for the gases that we're going to put in them. We're going to put 10 moles of gas A. We're going to put in 6 moles of gas B and 4 moles of gas C. That's going to give us 1 atmosphere for A, 0.6 atmospheres for B, and 0.4 atmospheres for C. We're also going to quit counting in moles. We don't need moles to do Dalton's law, so we're going to just think about it in terms of pressures. And now we're going to combine these amounts and make a mixture. So we're going to take each of these 3 containers and now push all those moles together into 1 container. It's easy to do the math. We now have 20 total moles in the container, and turns out that the pressures add up in the same exact way, and we get 2.0 atmospheres of pressure in the container. So to summarize, we've got 20 moles total. We've got 2 atmospheres of pressure. Now you need to remember the ideal gas law does not care what kind of gases you have. So 20 moles gives you 20 atmospheres. Now I'm splitting things back out on the right to show you the separate containers, and I'm also showing you the mixture. I'm going to put a dividing line here to show you that there's the 2 different ways we think. On the left is what the mixture holds. We just count number of moles. We don't care what they are. But on the right is more of the way a chemist sees things when he's looking at a mixture. We really see it as the 3 separate partial pressures that combine to give the total pressures. That's exactly what Dalton's law is all about. So the way I see this is partial pressure of A, the partial pressure of B, and the partial pressure of C all combine to give the overall total pressure in the mixture. If I take all those quantities and make a mathematical relationship out of them, I have the very definition of Dalton's law of partial pressures. We can also state this law in words. Dalton's law simply says that the total pressure of a mixture of gases is equal to the sum of the partial pressures. It's a very handy law, and it works for as many gases as you have in a mixture as you want. This has been Dr. Paul McCord talking to you about Dalton's law of partial pressures. Have a good day.
Okay. Bila bercakap berkaitan dengan gas, assumption yang kita guna pakai antara gas tiada tindak balas berlaku. Yang ni kena berhati-hati sedikit. Sebenarnya tindak balas ada berlaku between gas. Okay. For example, gas methane, when you heat it up, you form carbon dioxide and water. Or gas, hydrogen. Yeah. Gas hydrogen, when you heat it up or you bakarkan dia, burn it, you form water. So, kena berhati-hati di sini bergantung kepada soalan yang nanti kamu dapat. Dia akan bagi maklumat di situ yang kamu boleh guna pakai. So in particles, let's take a look at the particles. 1 mole is quantified of substance that containing 6.022 times 10 to the power of 23 particles of the substance, or Avogadro constant or Avogadro number. So 1 mole of oxygen, therefore 1 mole of oxygen atom will contain 6.022 times 10 to the power of 23 atom, and 1 mole of oxygen molecules, O2. Tengok, hati-hati ya. Di sini ada O2, ada 2 di sini. This one, oksigen 1 saja atom dia. It contain 6.022 times 10 to the power of 23 molecule or Avogadro number molecules. Molecules, but then if you take a look on the atom, it will be 2 times the Avogadro number atoms. Okay. Kenapa 2 di sini? Because over here ada 2 atom oxygen. And then if you take a look on the ammonia, another type of gas ammonia, molecule ammonia. Let's say 1 mole of ammonia molecule, NH3, it will contain 6.022 times 10 to the power of 23 molecules or Avogadro molecules. Okay. This one is Na lah. It's just Avogadro constant. Okay. But then, if you want to count the atom of ammonia, okay, because for ammonia ada 3 atom of hydrogen, also 3 atom of hydrogen, and 1 atom of nitrogen, so 4 atom. Okay, and 4 atom. That's why we need to 4 times Na Avogadro number lah, or 4 times 6.022 times 10 to the power of 23. And then if let's say you take a look on the 1 mole of magnesium fluoride. Magnesium fluoride is a salt, okay, ion. So it consists 6.022 times 10 to the power of 23 units fit. We count it as a unit, or 3 times 6.022 times 10 to the power of 23 ion. Okay, because MgF2, they associate with form Mg2 plus in water plus F minus. Okay. Okay. Stoichiometry. When we take a look at the stoichiometry, it is a balanced chemical equation. It is important because it gives us the number of mole of reactant and product, and then from the mass of the reactant or the product, we can calculate of it either one. From the product, we can estimate the amount of reactant that we require, or from the reactant, we can estimate the quantity, the product that we can produce, or the volume of gas. Okay. Okay, this one just example. Okay. NH2, N2, nitrogen gas. Oh, sorry. Nitrogen gas react with the hydrogen gas from ammonia gas, NH3. And then the equations need, because consists of nitrogen and hydrogen, it is quite simple. And then from there, you dah boleh seimbangkan dia. Dia senang saja. That means 1 mole of nitrogen produce 1 mole of nitrogen gas produce 2 mole of NH3, or 3 mole of, oh sorry, aku tak cantik ni. Three mole of hydrogen gas produce 2 mole of ammonia, or 1 mole of nitrogen gas will react with 3 mole of hydrogen gas. Okay. In stoichiometric calculations, you first It's very important. You need to balance the equations, chemical equations, the reactions too. And then you need to be able to convert. Sekejap saya nak check saya punya message. Sekiranya ada benda. Oh, kita tak apa. You need to be able to convert mass or other type of information that given to you to the mole. In which they use to can make it into a square or box to represent the substance with a known mass. And you can use the balance equation to set up the appropriate mole ratio and use it as triangle to represent the mole in the balance equations. From there, you can calculate the number of mole of desired reactant and the product. In a way, later on, saya akan guna circle to represent the desired reactant and the product. But then don't forget that to use the mole ratio and the mole from the known mass of the substance, reactant, and product. And then you need to convert from the mole back to grams later on, if required to you. Biasanya diminta ni, mole, from the mole you need to convert to grams, to the number, or to the number of atom, or to the number of molecules of desired reactant or product, depending on the type of problem that given to you. Okay. This is just example. Calculate how many grams of water that we produce from 10 grams of lithium hydroxide according to these equations. First kali saya nak tunjuk kepada kamu, kongsilah daripada cikgu saya, Cikgu Asia. Ini saya belajar di peringkat rendah dahulu sebelum masuk ke universiti buat degree. Beliau mengajar konsep yang sangat simple. Okay. First kali tengok reactions ni balance atau tidak, seimbang atau tidak. Seimbang in terms of number of atom on the left side and the right side. Okay. Daripada sini nak balas tu dah seimbang. Okay. Balas dah seimbang dah. So the soalan ni, the questions require you to calculate the number of gram of H2O. While information given to you related to 10 gram of lithium hydroxide. So you need to calculate first sekali, first tadi dah seimbang equation seimbang. Second, mole of lithium oxide. Okay, you need to calculate this one by equal to 10 gram divided with relative atomic mass of lithium with oxygen and hydrogen. Okay. From there, kita tengok daripada predicate table. Apa slow ni? Predicate sebenarnya pun dah terputus di sini. Lithium di sini, lithium 6.94 or 7 pun boleh juga. And oxygen 15.9999 or 16, and hydrogen 1. So 7 plus 1 plus 16, 7 is berapa dah? 7 plus 1, 8. Okay. Plus 60, 24. Betul ke? Kita check. Molar mass dia untuk lithium hydroxide 23.94 or 24. Okay. So from here, number of mole for masih tak cakap lagi dah menggunakan drawing pad ni. Mole lithium hydroxide 10 divided with 24. Okay. So from here you akan dapat apa ya? Okay. 0.42. Okay. Ini maklumat yang diberi kepada you all. You just change from a gram to mole of lithium hydroxide. But then from the stoichiometry reactions, 2 mole of lithium hydroxide produce 1 mole of H2O. One information for you yang ada data you diberi adalah 0.42 lithium hydroxide produce X mole of X, the quantity that we want to find out, the number of mole for water. So from there, you can do a cross in a way that you akan dapat X equal to X mole of water, 0.42, 0.42 divided with 2. Okay, and from there, 0.42 to 0.21, and this is a mole of water. For number of mole of water, you can convert kembali kepada mass of water. Okay. Or yang ni yang pelajar di UiTM Gemar guna pakai, yang mana yang punya penghafalan yang bagus, elok juga pakai yang ni. Pasti soalan yang sama. We know that lithium hydroxide, that we can say put it as a bracket, lithium hydroxide, and water in circle. So we can use the triangle to represent the number of mole in the balance equation for each bracket or circle, compound dia. So this case, 2 mole lithium hydroxide bracket produce 1 mole of H2O. Then we can make it something like this. Okay, so from there you dah tahu dah kedudukan dia macam mana. Okay. Yang ni dah melibatkan penghafalan sedikit. Yang mana yang cekap dari sudut penghafalan yang bagus ingatan, bolehlah pakai. Cuma saya tak berapa kuat, ingatan saya tak berapa kuat. So saya lebih suka menggunakan cara yang tadi, yang very simple one. 2 mole of lithium hydroxide produce 1 mole of water, and then the calculated number of mole for lithium hydroxide. From there, I calculate first the number of mole of water, and then convert from the number of mole of water into the mass. You know that mole equal to mass over relative atomic mass. Relative molecular mass, because it is molecule. Okay. And from there, let's say you need to calculate the number of molecules. Let's say, if you require to you just add the Avogadro number. In this case, this is you use triangle, circle, square. This is square mole of lithium hydroxide and relative molecular mass of water, H2O. So from there, you akan dapat about 3.766 gram of water. Okay. So another example, how many grams of oxygen are in the 200 gram of potassium hydroxide? Mass of oxygen equal to, if you have to use the concept of triangle, right? Triangle, atom oxygen, and then triangle for the group KOH. This one is a circle for potassium hydroxide times the mole of potassium hydroxide with the relative atomic mass of oxygen atom. So from there, you can calculate the mass of oxygen equal to 57.14 gram oxygen. And over here, untuk calculate how many gram of potassium hydroxide are required to produce 100 gram of potassium chloride. Okay. This is the reactions. First, check the reactions. Is it balanced or not? Okay. Pertamanya, kita nak balas itu perlu seimbang. Ini penting ni, kesilapan dari sudut seimbang, because these two ni, one over here is a stoichiometry factor. Silap di sini, silaplah kamu punya pengiraan kamu. Okay. And then untuk memudahkan you all, persamaan ini telah seimbang. Okay. So mass of potassium hydroxide, if you want to put the circle as a potassium hydroxide, and the triangle over here, this is a triangle potassium hydroxide. It is a mole, stoichiometry mole there, over potassium chloride, because the information given to you, potassium chloride saja ada, times the mole of potassium chloride and relative molecular mass of potassium hydroxide. So the mass of potassium hydroxide, this one is 2, okay, because you pick up from here. Okay. Another one, also 2, because you pick up from here, the balance station there. Okay. So ini 100 is 100 gram, and 74.5 ni it is K relative atomic mass of K potassium with the chlorine. Okay. And then times the 56. 56 it is relative, this one, relative molecular mass of potassium hydroxide. From there, just calculate, you obtain 75.2 gram of potassium hydroxide. Another example, let's say same reactions, almost same, same reactions. How many grams of magnesium chloride require or need to produce 100 grams of potassium chloride? Okay. Equations are more, chemical equation is more, and it is balanced already. But this time you are looking on your focus here, mass of magnesium chloride. So because of that, the circle, inside the circle adalah magnesium chloride, magnesium chloride, magnesium chloride. Okay. While for the square tu, still potassium chloride, because information yang ada adalah potassium chloride sahaja, just potassium chloride. Okay. So this the mole of potassium chloride. And mole of potassium chloride ni kita tahu 100 mass mole for KCl equal to 100 with the calcium plus Cl, relative atomic mass of calcium and Cl. Okay, so from there you can calculate the magnesium chloride there, 63.78 gram. Okay. So from same questions, soalan yang sama tu, you can obtain the information related to the reactant. It could be potassium chloride or magnesium chloride or information related to potassium hydroxide or magnesium hydroxide. Okay. For example, in this case, let's say same thing, same information, still the same questions, and that information still given to you 100 grams of potassium chloride, but this time you need to calculate the grams or the mass of magnesium hydroxide. Okay. But hati-hati, please be careful, be extra careful over here. You need to take a look. Apa ni? The equation must be balanced. The equation must be balanced. Chemical reactions there mesti balanced. Itu the first one. Okay. For this case, it's just a trick over here, a simple trick. Equations ni tak balance lagi. So you need to make it balanced. Yang mana the 2 KCl 2 KOH, just like before. And then if you calculate correctly, you will find out that the mass of magnesium hydroxide will be 38.9 gram magnesium hydroxide. Right. For the remitting reactant, tak banyak dah ni. Sekejap saya tengok. Rasanya dah tak banyak dah ni. Sekejap tengok. Banyak lagi. Guys, okey ke? Atau nak berhenti sekejap ke? Boleh, okey. Kalau macam tu saya teruskan lah. Kalau seperti tak ada. Macam mana ni? Nak rehat sekejap ke? Atau boleh saya teruskan? Siswa semua?
Prof.
Ya? Boleh saya teruskan ataupun nak rehat dulu sekejap? Ya, ya.
Halo Prof.
Ya, ya, ya. Nak rehat dulu ke sekejap? Take 5 minutes ke?
Boleh Prof.
Ya, take 5 minutes ya. Take 5 minutes.
Okey.
Rehatkan mata.
Turun minum dulu.
Minum dulu. Betul juga.
Okey Prof.
Take 5 minutes. Kemudian kita sambung lah. Ada sedikit lagi.
Okey Prof.
Baik. Okay. Ini agak critical, whereby you need to understand about delimiting reactant. The reactant that is completely consumed in the reaction, we call it as a limiting reactant. This reactant, while for the reactant that still remain unused or left after the chemical reaction, we call it as excess reactant. So just to imagine about limiting reactant ni, you can pick up a piece of paper, you can burn it, and then dia akan terbakar and start to burn until there will be no more paper. Okay. But still, to burn a paper, you require oxygen, at least a paper and oxygen, and a bit of heat to burn, to starting the catalyst there. When you burn material paper tu, at certain time, after certain time, it totally burn out, finish, complete, but oxygen still there. Excess dia adalah oxygen, limiting reactant dia adalah paper. So the reactant in which is used up first in the chemical reactions. So the mole of limiting reactant will always be less or used regarding the chemical equations. And then the mole of excess reactant are more used in comparison to chemical equations. Okay. For example, reactions between the ammonia and copper oxide. Okay. In a way that you produce ammonia gas, copper, metal, solid, and water, H2O, also in gas form. And then the mole too, first you need to make sure the reactions balance, the chemical equations tu adalah balance, seimbang. So ini dah seimbang sudah. So from here, you know that on the balanced chemical equations, you know 2 mole of ammonia will react with 3 mole of copper oxide. Okay, 2 mole ammonia react with 3 mole of copper oxide. Okay. So if information given to you related to mass of ammonia and copper oxide, let's say mass there 10 gram to ammonia, while for copper oxide 40 gram, or you can designate there as X or Y. From there, you can calculate the ratio mole for ammonia and copper oxide. Okay. Calculate the mole of ammonia and copper oxide. Okay. The calculated mole there the X ni adalah calculate mole for ammonia, while for Y, the calculated value for copper oxide. So individually, when you calculate the mole of ammonia, let's say 10 gram of ammonia, take a look from the say sana, 10 mole of ammonia, and ammonia saya terlupa dia punya number dia. NHT 14, 70. So 10 more, 10 gram divided with 70, you akan dapat 0.59 mole of ammonia. Yang tu calculated value dia. While for copper oxide, 16 plus, where is the copper? Cu, 60, 64, 80, 40 bagi 80, 0.5. So here, one of it 0.5, satu lagi tu saya dah terlupa dah. Ini masalah saya ni. Okay. So from there you can ratio the calculated value of ammonia to the copper oxide. Okay. And at the same time, you can calculate the ratio of it for copper oxide to the ammonia. Okay. And then you need to compare with the ratio of mole given in a balanced equation. If one of it negative, that means the value negative less than the mole of a balanced equation, that means it is a limiting reactant. If ammonia is the limiting reactant, so the copper oxide become the excess reactant. And this situation vice versa. Nah? Let's say the copper oxide become the limiting reactant, the excess reactant will be the ammonia. Okay. This is the calculation. Calculated mole, as always, mole equal to mass over the relative molecular mass. And depending on the situation, it may be based on molarity over volume times volume. Once the limiting reactant is determined, we dah tahu dah limiting reactant dia, all the calculation will be referred to the limiting reactant, the mass of the limiting reactant. Okay. Okay. Thereafter, the mass or product or mass of excess reactant should be based on the mole of limiting reactant. So the excess reactant equal to the initial mass of the excess reactant. Remain minus with the mass of the excess reactant react. Initial mass of the excess reactant minus the mass of excess reactant react. Ini a simple example. In a way that which limiting reactant 100 gram of N2H4 react with 200 gram of N2O4. Okay, you need to calculate the mass of the excess reactant. Chemical reactions ni first kali, you need to take a look. Is it the chemical reaction balance atau tidak? If it is balanced, then okay. Simple, you can guna pakai terus chemical reactions ni. If it is not balanced, then you need to balance it first. Ingat, balance the chemical reactions. Balance the chemical reactions. Very, very important. Okay. So when you balance the chemical reactions, the stoichiometric mole there, 2 mole N2H4 and 1 mole of N2O4. And then you need to calculate for each mole for N2H4 and N2O4. So when you calculate it, you obtain about 3.125, another one 2.17. And then you can do a ratio between these two. From there, you dapat 1.437, the ratio of it. Another one, 0.696. So the ratio given in balance equation, yang ini 2 divided with 1, and another one 1 divided with 2, it is 0.5. So for last step dia, untuk determine the limiting reactant dia, pick up the ratio yang awal tu, and minus 2, the ratio yang ini, which is a negative. Value dia tak penting, but you know it is negative, it is sufficient. So when it become negative, it means that N2H4 is a limiting reactant. Just to check saja, 0.696 minus 0.5, the result will be positive value. So N2O4 become the excess reactant. So from here, mole yang ni, starting from here, and you know the N2H4 adalah limiting reactant, you will always use this mole, 3.125. Okay, later on, untuk calculations, let's say the amount of water produced, or the amount of gas ammonia. While for the excess reactant, that remains equal to the initial mass of the excess reactant minus the mass of excess reactant react. Yang reactnya sedikit saja. Okay. So mass of N2O4, excess reactant, ratio dia, kita tahu dia equal to the ini stoichiometric ratio dia. Kalau ini, sebelum ni kita dah tengok dah 1/2, this one, kasihnya satu ni kita tak tulis lah. Okay. Satu tu kita tak tulis di sini. Times the mole of N2H4 times the reactive molecular mass of N2O4. Okay. And from there, kita akan dapat about 143.75 gram of mass of N2O4. So the excess that remain, awalnya, initial ni, N2O4 ni adalah 200 gram, and then reactions require about 143.75 grams saja for the reaction to be complete, and therefore you have the excess of 56.25 gram of N2O4. Ini contoh yang sama seperti tadi kita guna pakai semua ni, dan mekanisme dia hampir sama, cuma informations yang ada 10 gram of potassium hydroxide and 10 gram of magnesium chloride. Previously, you only concentrate on the magnesium potassium hydroxide, potassium hydroxide. Itu saja maklumat yang ada, potassium hydroxide. So the calculated mass of the potassium chloride, for this case, amount of potassium chloride that we produce, that can produce. Okay. Mechanism, first kali, take a look at the mechanism. Luckily for you, this time, the mechanism tu adalah balance sudah. Balancing sudah. Seimbang sudah. So from there, ini agak sistematik sedikit lah. Kalau you nak buat pakai macam ni, tak ada masalah. You boleh pakai dengan cara yang diintroduce oleh cikgu saya dulu, Cikgu Asia. Yang ni 2 more potassium hydroxide, stoichiometry ratio dia, mole dia, and 1 mole of magnesium chloride. Ini require dia for balance chemical reactions. So number of mole for each reactant 0.17 potassium hydroxide, while for magnesium chloride 0.105. And the ratio between it 1.704 and 0.587. Ratio based on chemical balance chemical reactions or balance equations. 2 added with 1 equal to 2, while for this one 1 over 2 equal to 0.5. Okay, so you just need to minus step 3 minus step 2, 1.0 minus 1.04 minus 2, you obtain a negative value that will mean that lithium lithium, so that means potassium hydroxide will be the limiting reactant. Okay, because of that, the excess reactant will be magnesium chloride. From here, dah dapat dari ni, dah confirm dah potassium hydroxide adalah it is a limiting reactant. So you will concentrate the mole of potassium hydroxide. We go to potassium hydroxide sekarang ni. Only use the mole of potassium hydroxide. Okay. So again, just rewrite balik balance chemical reactions there, equation there. Potassium hydroxide, KOH, adalah limiting, it is a limiting reactant, and R. So mass of any required for you to find out mass of potassium chloride. So mass of potassium chloride, if you based on the circle and square formula sebelum ni, 2 KCl divided with 2 KOH times mole of KOH and times the relative molecular mass of KCl. And from there, you akan dapat 13.33 gram of KCl. And then let's say that it's required for you to calculate the excess reactant that remain. So again, you can calculate mole KOH that you calculate dah sebelum ni 0.179. Yang ini based on stoichiometry, yeah. So times 95 is 95 adalah yang ni relative molecular mass of magnesium chloride. So from there you dapat tahu magnesium chloride is a 8.5 gram. So the excess magnesium chloride remain awal dia before the reactions, magnesium chloride 10 gram. After the required amount of magnesium chloride for a complete reactions 8.5. So excess dia will be 1.5 gram of magnesium chloride. And then normally, after reactions, we calculate the percent yield. Because the maximum quantity of the product that could be formed in chemical reaction, we call it as a theoretical yield. Okay? Maximum quantity, or some may put it as a calculated value of a product, we call it as a theoretical yield. Apa benda tu calculated value? Inilah yang you calculate tadi, KCL. Calculated value dia adalah ini. Okay. You calculate menggunakan formula. Call it as a theoretical yield. Okay. While for the actual yield, it is the amount of product obtained from the reactions. Amount macam mana? Yang you timbang, yang you measure it. Okay. So we conclude that the amount of product in the form of percent yield, whereby percent yield equal to the actual yield times 100% divided with the theoretical yield. So percent yield, the value from the experimental, are given in the equations to give or to produce, while for the theoretical yield, calculated value of the product. Okay. This is just a simple example of it. Let's say if 225 gram of carbon react with the excess of sulfur oxide, the amount of sulfur oxide ni banyak, lot. In a way, it produces 195 gram of calcium sulfide. Calculate the percent yield for the reactions. Okay. This is the mechanism, the reactions here. Okay. It is a balanced reaction sudah. Percent yield, itu the value from the experimental. Yeah, produce, yani produce tu that mean the value from the experimental, but then problem dia, you tak ada information related to the theoretical yield dia. So you need to calculate the theoretical value dia, theoretical yield dia. So given to you 225 gram of carbon, and then a lot of sulfur oxide. So sulfur oxide, you dah tahu dah, it is a excess reactant. Okay. So from here, as always, the mass for carbon, if you want, any equal to the circle, you put the circle divided with the square, this is the base of mole, times the mole of carbon, and times the relative molecular mass of calcium sulfide, carbon sulfide, calcium sulfide product. So, because based on balanced chemical reactions, satu saja, only one carbon sulfide produced with a 5 mole of carbon, a reaction of 5 mole of carbon. So here will be 1. This, then over here will be 5. Okay. Mole of carbon, you can calculate 225 from here. And relative atomic mass of carbon equal to 12. So times 76, it is relative molecular mass of carbon sulfide. So the theoretical value should be 285 gram. 285 gram. Thus, percent yield dia 195 times 100 divided with 285. From there, you obtain 68.42%. Okay. For the calculation, previous calculation, you take a look on the mole side, but then you all pun ada juga tindak balas or reactions or calculation that require you the condition will be in the solution, your reactant in the solution. So for calculation related to a solution, we go to the concentration, the formula there. In a way that we can base on the molarity, which is equal to the mole of solute divided with the mole of solution in a liter or decimeter, cubic decimeter. So the unit for molarity, it is a mole per liter or mole per cubic decimeter or molar. Okay. So the concentrations equal to molarity times the molar mass. So the concentration juga, the unit could be either gram per liter or gram per cubic decimeter. And then for mole of a solute equal to the molarity times the volume of the solution. This is a common unit of the concentration. Okay. It could be mass of solute divided with the mass of solution, okay, or mass of solute over volume of solution, or in ppm, in a way that part per 100 per million. It could be gram of solute over 10 to the power of 6 gram of solution, or microgram of solute divided by milliliter of solution. Okay. Or ppb, part per billion, gram of solute over 10 to the power of 9 gram of solution, or you can put it in nanogram over milliliter. Okay. So what I mean by solute? Solute, again, solute, it is a substance that being dissolved and it is present in a less amount compared to the solvent. For example, salt, garam, gula, sugar, syrup, orange, sunquid, and then so many, and others. While for solvent, it is a substance that does the dissolving of the solute. It present in a larger amount. For example, it could be water, alcohol, hexane, and so on. Benzene pun boleh, or even THF, tetrahydrofuran. Okay. Yang ni you can try, calculate the number of mole and the mass in the gram, mass in gram of sodium hydroxide that can be dissolved in 100 milliliter of 2.0 molar sodium hydroxide solution. Okay. Or this is a simple situation yang you akan hadapi, yang dihadapi di pelis ni, iaitu pelis ni, pelajar kami, kita dedahkan. And then the molarity, mole per liter, and concentration of solution formed from 56.0 gram of potassium hydroxide when it is dissolved in 200 cubic centimeter of solution. I mean over here, to dissolve potassium hydroxide ni, we use water lah, directly. So when you calculate solution, calculation kamu related to a solution, please be careful. You need to convert the given volume to a liter first. please be careful over there. Volume to liter first. Okay. So dilution factor tu berhati-hati. Dilution table conversion factor tu over here the conversion factor lah. Conversion factor ni you need to take a look on the previous slide. Saya dah bagi dah kepada you all. Dah discuss dah previously. For dilutions, it is a process of changing the concentration of solution from high concentrated solution to low concentration. So during the dilutions, amount of solid remain the same. Number of mole dia sama saja. But then the volume change from V1 to V2. Okay. The additions of solvent do not change the amount of solute in the solution, but only change the molarity of the solution. So in a way then, the formula for dilutions, we can make it as M1, molarity 1, V1 before the dilutions equal to M2, V2. Okay. Which indicate one is initial, while two indicate a new or final concentration or volume or condition there. For example, this case, how many cubic centimeter of 10 molar HCl, hydrochloric acid, stock solution that would be used to prepare 5.0 cubic decimeter of 0.5 molar HCl. So again, trick dia. Decimeter to centimeter. Okay, decimeter to centimeter. So please be careful over there. Okay. Perhaps you can start with calculating with in the decimeter first, unit in decimeter, in a way that based on formula previously, M1 V1 equal to M2 V2. So 0.5 times 5, you get V1 ni divided with 10. Okay. You akan dapat 0.5 cubic decimeter. But then to change it to the centimeter, okay, you kena ingat deci to centimeter 10 to the power, Allah Akbar. The difference is 10 to power 10 to power minus 1 from deci to centi. Centi to deci, centi lagi besar, lagi kecil. Sorry, centi lagi kecil. Kita deci. Okay. So, but then it is in a cubic. So you need to times 3 because it is from yang besar kepada kecil, that means it become 0.25 times 10 to the power of 3. So equal to 250 cubic centimeter. Okay, ini you can try. Let's say a student measure 150 milliliter of 0.5 molar HCl and transfer it to a volumetric flask or beaker, and then later on you add water, distilled water, until the solution become 1 liter. So 150 milliliter, V1 to V2 dia, final one dia become 1 liter. So be careful lah. Liter to milliliter to liter. Milli 10 to the power of minus berapa di sini? Okay. And this is a exercise, simple exercise, stoichiometry, and a bit exercise related to the gas law. And then with that, kita tamatlah kita punya kelas lecture for today. Okay guys, so ada di mana saya tekan? Ada persoalan ya? Baik. Ya. Agak letih sikit lah. 2 jam kelas ni. Lecture note tu dia dapat daripada link yang saya bagi.
Kenapa, Bro?
Link, saya dah bagi link di situ untuk lecture note. And then ada a few exercise yang sesuai jugalah untuk student jawab.
Ya.
Tapi exercise tu kena asing lah. Because melibatkan mekanisme sedikit.
Ya. Oke, sob.
So saya kembali kepada doktor ni. So,
Sudah selesai, Prof?
Ya, dah. Sudah. So,
Sudah, oke.
Ada persoalan ke daripada siswa-siswi?
Oke, ada yang ingin tanyakan ke Prof Razifnya? Jovin Markuri.
Ada. Di mana tu?
Jovin, bisa dengar suara saya?
Dalam tempoh 2 jam ni memang letih sedikit. Kalau kelas 2.
Dena Suci Apriani.
Hadir, Pak.
Oke, ada yang ingin tanyakan?
Mungkin selepas ini, bila siswa semua tengok soalan tu, daripada exercise tu, sekiranya ada masalah, boleh kontak saya through WhatsApp. Okay? Terima kasih. Tak perlu segan untuk. Boleh kongsi.
Oke.
Dia tak ada bayaran kan? Kita ada extra charge kalau kita menggunakan WhatsApp kan?
Tidak, Prof.
Tak ada itu. So, jangan risau. Siswa semua jangan risau.
Free ya, Prof ya?
Free je. Jangan risau. Bagi peluang kepada saya untuk tambah pahala.
Siap.
Bagi peluang.
Ada lagi yang ditanyakan pada mahasiswa? Gama Malik. Mana orangnya Gama Malik?
Ya Pak, hadir.
Ada yang tanyakan Gama?
Nggak ada Pak.
Oh, nggak ada ya. Bisa mengerjakan exercise dari profnya ya?
Oke Pak.
Oke.
Alhamdulillah.
Nanti profnya bakal kirim ke saya itu yang kalian kerjakan itu ya, Prof ya?
Ya, boleh. Saya akan bagi.
Sekitar seminggu lagi lah, Prof, karena yang saya bakal share dulu ke 2 lokal lainnya gitu.
Boleh.
Boleh,
Tak ada masalah. Biasa lah tu. Ya.
Supaya rata semua dapat materi dari Prof-nya.
Ya, ya. Yang penting semua boleh belajar.
Ya, siap Prof.
Oh, ya.
Sepertinya tidak ada pertanyaan, Prof. Mungkin ada lagi yang disampaikan, Prof, closing statement-nya.
Untuk dari saya dah tak ada dah. Cuma kesilapan biasanya untuk daripada pelajar yang sangat-sangat menyedihkan. Asas tu balance tu. Chemical equation itu yang kesilapannya kritikal.
Oke.
Silap di situ habis markah semua kali. Tak ada dah markah.
Chemical balancing itu, Prof, ya?
Very critical. Berhati-hatilah.
Oke. Menyetarakan reaksi kimia kalau di Indonesia biasa lebih familiar di itu ya.
Reaksi kimia.
Iya. Oke, mungkin bisa ditutup, Prof, kalau tidak ada lagi.
Kalau kita terima kasih daripada saya dan UiTM juga kerana jemputan.
Ya.
Dan kita boleh buat lagi kelas tambah, lecture tambahan bergantung kepada permintaan lah, keperluan. Boleh tak?
Oke, terima kasih saya ucapkan kepada Associate Prof. Dr. Razif Muhammad Nurdin atas waktunya telah memberikan kuliah kepada kita semua tentang kimia dasar atau basic chemical, baik itu sebelum UTS kemarin atau before midterm kemarin dan sekarang gitu. Artinya udah 2 kali pertemuan dengan Prof. Dr. Razifnya. Saya harapkan semua mahasiswa bisa menyerap ilmu yang diberikan oleh pematerinya. Semoga menjadi amal untuk Dr. Razifnya ya, Prof, ya.
Ya, betul.
Dan kalau ada yang ingin ditanyakan, bisa dihubungi via email atau WhatsApp ke Dr. Razifnya. Mungkin itu saja. Saya tutup kelas kita di siang ini, dari pagi sampai siang maksudnya. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Oke, silakan.
Terima kasih, Prof.
Terima kasih, Pak.
Terima kasih, Pak.
Terima kasih, Pak.
Terima kasih, Pak.